Welcome to the deep dive. Today we're diving into GMSL2, a serial link technology from analog devices.
Okay,
We got a bunch of info from you, especially their user guide.
sounds good.
Seems like you're really interested in connecting multiple devices, especially how to connect two serializers to a single deserializer.
Mm-hmm.
We'll also explore what GMSL2 can do. Expert speaker, ready to decode.
Absolutely. GMSL2 is fascinating.
Okay.
It has extensive capabilities, like a high-speed, multi-lane highway for data, designed for those demanding applications you're looking at.
Okay, so more than a simple connection.
Right. It uses a packet-based bidirectional communication system.
Interesting.
Separate channels for sending and receiving data simultaneously. 3 Gbps or 6 Gbps speeds.
Wow.
And this speed is independent of the video pixel clock, not common with every serial link technology.
That's pretty impressive, like a dedicated express lane for data no matter the video traffic.
Yeah.
Speaking of traffic, the guide mentioned coaxial and differential pair cables.
Yeah.
What's the difference?
Great question. GMSL2 works with both. 50 coaxial and 100 differential pair cables. Different roads on our data highway. Coaxial cables are robust, good for longer distances.
Okay.
Differential pairs offer better signal integrity, especially at higher speeds. The best choice depends on your needs.
Interesting. So the right tool for the job.
Right.
I'm curious, how do these GMSL2 devices start up and get ready to transmit? Is there a sequence?
Good point. Like any complex system, it has a specific power-up sequence. When the PWDNB pin is low or power supply drops below a threshold, it powers down. Power-up starts when the PWDNB pin is high and power supply is above that threshold.
Makes sense.
No strict power supply sequencing required. But good practice to enable all power supplies first, then activate the PWDNB pin.
Like turning on the highway power before the cars. Makes sense. What happens next?
Configuration phase. It reads its configuration pins and sets internal registers, like setting the traffic rules for our highway, speed limits, lane assignments.
That makes sense. How do we know if everything's set up right and the link is working?
The LOCK pin, or register. You must monitor this signal.
Okay.
To confirm the GMSL link is locked and ready. The green light at the highway entrance, if it's not lit, something's wrong.
Okay, the LSCK signal is our all clear. The guide mentioned periodic adaptation. GMSL2 is constantly adjusting itself. Is it learning?
Not traditional AI learning, but it self-optimizes.
Oh, yeah.
Constantly monitoring the link, adjusting its parameters to maintain optimal performance. This helps it cope with things like temperature changes or even cable aging. It's like a road crew constantly repairing and repaving our highway to keep traffic flowing smoothly.
That's incredible, a self-maintaining highway. How often does this adaptation happen?
By default, every second, ensuring the link's always at peak efficiency.
Wow.
The guide has these eye diagrams illustrating how GMSL2 optimizes the signals.
Cool.
Figures 4 and 5, if you want to see them.
Okay, so we've got our data highway up and running, constantly fine-tuned.
Yes.
Now connecting two serializers to a single deserializer. This is where it gets interesting.
You're right. This is where we see GMSL2's true power and flexibility.
Okay.
Imagine two data sources, each with its own serializer. You want to send both data streams to a single destination. This is where reverse splitter mode comes into play.
Reverse splitter mode, what's that?
It means we're configuring the deserializer to receive and process two separate GMSL2 streams. Think of it like having two separate highways merging into a single, larger highway.
Okay, starting to get the picture. But how do we prevent data stream collisions or mix-ups?
Crucial consideration. First, ensure each serializer has a unique I2C address. I2C is how we configure and control these devices.
Okay.
If both serializers have the same I2C address, it's like sending mail to two houses with the same address confusion.
Right, clear communication.
Exactly.
So we assign each serializer a unique address. What's next?
Once we've handled addressing, we need to configure the deserializer to operate in reverse splitter mode.
Okay.
We use the LENKCFG register, the control panel for the deserializer.
So we're saying, hey, get ready to handle 2 lanes of traffic.
Exactly. Then, after configuration, we initiate a link reset.
Got it.
Ensures new settings take effect, and the connection is properly established. Restarting traffic to make sure everything's running smoothly with the new configuration.
Got it. So we've configured the serializers with unique addresses, set the deserializer to reverse splitter mode, and initiated a link reset. How do we know if it's all working?
Our trusty LOCK pin. We need to monitor it again. Once it goes high, we know both serializers have successfully connected to the deserializer, like seeing those two lanes of traffic merging seamlessly onto our larger highway.
Okay, the LOCK pin is our confirmation signal. Now, the guide mentioned I2C address translation. I'm a little confused about that. What is it?
IDC address translation is a powerful tool, especially when you have multiple devices that might share the same I2C address. It allows us to map one I2C address to a different virtual address.
Okay. Can you give me a real-world example of that?
Sure. Let's say you have two identical camera modules, each connected to a serializer. And for some reason, both camera modules have image sensors that use the same I2C address for communication.
That sounds like it would cause problems.
Exactly. If you try to send I2C commands to control the cameras, you won't be able to target them individually since they share the same address.
Right. It's like trying to call two different people who have the same phone number.
That's a great analogy. Here's where address translation comes in. By enabling address translation in the serializer, we can assign each camera module a unique virtual I2C address, even if their physical addresses are the same.
So like giving each camera its own dedicated phone line, even though they share the same physical connection. That's really clever.
It's all about clear communication and avoiding conflicts, even in complex systems.
Okay, so address translation is crucial for managing I2C communication, especially with multiple devices that might share the same physical address. But I'm also curious about GMSL2's broader capabilities. We've talked about high-speed data transmission, but what else can this technology do?
You're right, we've only scratched the surface. GMSL2 is much more than just a data pipe. It's packed with features that enhance reliability, security, and even video processing capabilities. Let's take a closer look. Welcome back to our deep dive into GMSL2.
It's great to be back.
Yeah.
I'm excited to hear about those extra features you mentioned. We've covered the basics of connections, but what makes GMSL2 really stand out?
One of the standout features is its error detection and correction. You know, in any high-speed data system, errors are bound to happen.
Yeah, makes sense. Especially with gigabits of data flying around, small errors could be a big problem.
Exactly. But GMSL2 has this built-in mechanism called forward error correction, or FEC. Acts like a road repair crew, scanning for errors and fixing them on the fly.
So the data gets through safe and sound.
Yes, even with noise or interference.
That's pretty amazing, a self-healing highway. Any other safeguards?
Absolutely. GMSL2 can embed invisible watermarks within the video stream.
Invisible watermarks, like on money to prevent counterfeiting.
Exactly the same idea.
Yeah.
For authentication and security.
Oh, great.
To verify the integrity of the video data, ensuring it hasn't been tampered with. Like a secret code embedded in the signal, only authorized devices can recognize.
So it keeps the data safe. That's clever. We talked a lot about data, but the guide also mentioned video processing features. Can you tell me more?
GMSL2 is more than a data pipe, it's a video processor. For example, it has a video timing generator, VTG.
Okay.
It generates or modifies the sync signals that are essential for video display sync.
So everything stays in sync.
Yeah, like a conductor, making sure all the instruments are playing in harmony.
Great analogy.
Yeah.
And what about the video pattern generator?
Right, the VPG. It generates test patterns for debugging and testing the video system, making sure it's working correctly.
Like a built-in diagnostic tool.
Exactly. Then there's color lookup tables, or LUTs.
Okay.
Allow for precise color adjustments, like a digital color palette to fine-tune the video image colors.
Okay, so we can adjust the colors.
Yeah. GMSL2 handles timing, generates test patterns, and even adjusts colors.
Quite a toolbox. What about audio? Can it handle that too?
Of course. GMSL2 supports I2S and TDM audio formats, bidirectional audio transmission.
Bidirectional, sending and receiving simultaneously.
Exactly. A two-way radio for audio signals, perfect for applications like video conferencing or car entertainment systems with audio going both ways.
Okay, so video, audio, check. What about control and communication? How does GMSL2 manage that?
GMSL2 offers a variety of control options. Primarily, it uses I2C and UART interfaces, which are standard protocols used in lots of systems.
Well, I'm familiar with those. Any other options for specialized applications?
Yes, it also supports SPI and GPIO interfaces,
Wow.
providing more flexibility for controlling and communicating with different devices.
So it's like GMSL2 can speak multiple languages.
Exactly. This flexibility and features make it a powerful and adaptable solution for many applications.
Earlier, you mentioned there's more to explore about connecting two serializers to a single deserializer. I'm interested in I2C address translation and how it manages multiple devices with potentially conflicting addresses.
Right. That's key when working with multiple devices in a GMSL2 system. Let's dive into how address translation works and why it's so important.
I'm ready. Let's start with those two camera modules, each connected to a serializer. How do we use address translation to control each camera independently, even if they share the same I2C address?
First, we need to understand how I2C communication works. Each device on the I2C bus has a unique address to identify it.
Okay,
When you send an I2C command, you specify the device's address you want to talk to.
makes sense, like dialing a phone number.
Exactly. If two devices have the same address, it's like two people with the same number. You won't know who you'll reach when you call.
That's where address translation comes in.
Exactly. With address translation, we assign each device a virtual address different from its physical address, a temporary nickname for the communication.
Okay, so they have different virtual addresses, even with the same physical one. Brilliant.
It avoids conflicts, ensuring each device can be controlled individually. In this case, the address translation happens in the serializer.
The serializer is the translator. But how does the deserializer know which virtual address goes with which camera?
That's where configuration comes in. We program the deserializer with a mapping table.
Okay.
It tells the deserializer how to translate the virtual addresses back to physical ones.
Like a directory.
Right. It lists the virtual and their matching physical addresses. When the deserializer gets a command with a virtual address, it looks it up in the mapping table and forwards it to the correct camera.
So everything goes to the right place.
Yes, smooth and accurate communication, even with multiple devices sharing the same bus.
Okay, that's great. Let's talk practical steps. How do we set up address translation in a system with two serializers and one deserializer?
Sure.
First, configure each serializer with a unique I2C address, so we can talk to each serializer individually.
Right. These addresses are for communication between the main controller and the serializers, not the cameras.
Good point. Then we need to enable address translation within each serializer, setting specific bits in the configuration registers, right?
Exactly. Telling the serializer to be ready to translate virtual addresses.
Okay. What's next?
Next, configure the deserializer. This is where we set up that mapping table.
Oh, right.
Each entry has a virtual address and its physical address.
It's like a lookup table. How do we decide which virtual addresses to use?
You have some flexibility. You can choose any as long as they don't clash with other addresses on the I2C bus.
So they need to be unique. Once the mapping table's in the deserializer, are we done?
Almost. We initiate a link reset.
Okay.
This makes sure all the new settings, including address translation, take effect, like rebooting the system to run smoothly with the new configuration.
Got it. So then we can talk to each camera independently using their virtual addresses.
Exactly. Address translation is a powerful tool for complex systems, preventing communication conflicts.
Now, I know connecting two serializers to one deserializer is big in automotive applications. Can you give some examples of how this is used in a car?
Sure. One is in surround view camera systems. Many modern cars have multiple cameras, providing a 360-degree view.
Right, those are super helpful for parking in tight spaces.
Exactly. Each camera has its own serializer. Video streams from all the cameras go to a single deserializer in the car's infotainment system.
So the deserializer is the central hub.
Yes.
And with address translation, we can control each camera individually. What other automotive applications are there?
Another is Advanced Driver Assistance Systems, or ADS. They use cameras and sensors for things like lane departure warnings, blind spot detection, and adaptive cruise control.
Those are getting really popular in new cars.
They are. They often use multiple cameras. GMSL2, with its multi-serializer capability and address translation, is perfect for connecting and managing all those cameras.
Okay, so GMSL2 can handle multiple data streams and complex communication, making it ideal for modern cars.
You're absolutely right. Its versatility and robustness make it a key technology driving innovation in the automotive industry and beyond.
Wow, GMSL2 really is a powerhouse.
It is.
We've learned so much about data transmission, error handling, even audio and video processing. What else can we explore about GMSL2's capabilities?
Well, we've covered a lot, but GMSL2's adaptability goes even further. Let's look at how it integrates with other industry standard interfaces.
Okay, like what?
One important one is OLDI, the Open LVDS Display Interface. It's often used in those automotive infotainment systems.
OLDI. That's a new one for me.
It's becoming more popular, particularly for connecting displays in cars. GMSL2 deserializers can actually have OLDI outputs. They can directly drive displays that use this interface.
So the GMSL2 deserializer can speak OLDI directly. No need for extra components to convert signals.
Exactly. Simplifies system design, makes things more cost-effective.
Okay.
Especially helpful when space is limited, like those rear seat entertainment systems.
Right, those screens in the back of headrests. Streamlined connection makes sense there. Any other examples of GMSL2 and OLDI working together?
Of course. Digital instrument clusters. All those fancy digital dashboards in modern cars. GMSL2 and OLDI can team up to drive those high-resolution displays. Crisp and clear visuals for gauges, warnings, all that.
Okay, so from entertainment to driving info, GMSL2 and OLDI are behind a modern driving experience. How do you actually set up the OLDI output on a GMSL2 deserializer?
It's pretty straightforward. Dedicated registers on the deserializer control the OLDI output. You define things like data format, the number of data lanes, voltage levels, all that. It's software controlled, very flexible.
So we can fine-tune the output for the display.
Yeah.
And I guess those status registers we talked about earlier are important here too.
Absolutely. You can monitor those registers to make sure the OLDI output is locked onto a valid signal, transmitting data correctly, like a diagnostic system for the display connection.
Makes sense. So GMSL2 is also connected to the MIPI CSI2 interface, used for cameras and image processors. Can you explain that?
Sure. IPI CSI2 is a high-speed protocol designed for camera data. GMSL2 serializers and deserializers can have MIPI CSI2 interfaces built in.
Okay.
They can transmit high-resolution video from cameras smoothly.
So instead of connecting a camera directly to an image processor, which might be far apart, GMSL2 bridges the distance.
Exactly. That's why it's so common in automotive applications like rear-view cameras. Imagine running a long cable directly from the camera to the dashboard. Impractical and prone to signal loss.
Yeah, that wouldn't work very well.
With GMSL2, you can send that high-bandwidth video over a single coax cable or shielded twisted pair, and the signal stays strong over longer distances.
Much more robust and efficient. Can you walk us through how a GMSL2 serializer works with a MIPI CSI2 camera?
Okay. The serializer has dedicated MIPI CSI2 input lanes.
Okay.
They connect directly to the camera's output lanes, a direct connection to capture the camera data. Then the serializer converts that MIPI CSI2 data into the GMSL2 format to send over the link.
Okay, and what happens on the receiving end? How does the deserializer handle that GMSL2 data?
The deserializer does the opposite. It has dedicated MIPI CSI2 output lanes that connect to the image processor
Okay.
or whatever device is getting the video data. It converts the GMSL2 data back to MIPI CSI2 format, so there's smooth communication with the receiving device.
It's like a translator for both GMSL2 and MIPI CSI2. This whole system is so well designed.
It is a great example of industry standards working together.
Yeah.
The cool part is GMSL2 serializers can even handle multiple MIPI CSI2 streams at the same time.
Multiple streams. That seems complicated. How would that work in a real application?
Think about it, guys. These systems often have multiple cameras around the car. Instead of separate cables for each camera going to the CPU, a single GMSL2 serializer can combine those streams and transmit them over one GMSL2 link.
That's a much cleaner setup.
Yeah.
So from infotainment to driver assistance, it seems like GMSL2 is a big part of how cars are evolving.
You got it. Its ability to handle high-speed data, multiple streams, different interfaces, it's key for the sophisticated electronics we see in today's vehicles. And it's not just cars. You'll find GMSL2 in industrial automation, medical imaging, many other fields.
It really is versatile. We've gone from connecting two serializers to one deserializer to seeing how GMSL2 impacts so many industries. This deep dive has been amazing.
I agree. GMSL2 shows what innovation and collaboration can do. It's pushing the limits of high-speed data transmission, making so many new applications possible.
And to our listeners, if you want to learn more about GMSL2, check out the user guide. There's a ton of information there.
For sure. The more you learn, the more you'll see how powerful GMSL2 is.
Well, thanks for joining us on the deep dive today. It's been a great exploration of GMSL2. Until next time, keep exploring.